started. Again, welcome to Monday. Happy homecoming week and all of that. Just a couple of details that I want to talk through with you before we get started too far into things. We're going to start with a warm-up problem today. We'll do some work with some sign values, positives and negatives, and then probably get to some motion problem solving as well. This is the homework that was written down to be for today. I am not confident that we will get that far. I will let you know at the end of the period, okay? If it's not this, it may be something else, and I will let you know which of those things it is once we get to the end of the period today, okay? A couple of other little logistical things before we get into things, into the physics of our day. One is that I know that people have been asking a lot about grades and when grades are going to be posted and all of those things. And I very much appreciate your patience as I'm kind of getting things set up. I spent, I want to say, maybe about 4 hours yesterday working with the gradebook system and trying to figure out the best way to do it so that I can most cleanly communicate to you how you're doing on the standards, okay? I have that now set up, but I do need to put grades in so that it actually looks like something. My goal is to get that done tonight, and assuming that I do that, I will introduce you to the grading system tomorrow during class. Okay, that's my plan. That's my goal. That's one thing that I wanted to share with you. The other is a little bit of a logistical piece that I wanted to communicate to you as well. I generally, in physics classes, ask partway through a period or at the beginning of a period, does anybody have any homework questions? And honestly, friends, with as many people as we have in this room, it just makes it kind of hard to do that overall and to plan well. So what I've done is on the Canvas class page, underneath where the textbook is, you guys have seen this and you use it every day or plus or minus a little bit. And then the course videos, the next thing down is a homework help request. So what I did is I just put together a Google form. And the Google form, my goal is that it will help you to communicate with me if there's a problem you want to go over in class, okay? So while you're working on your homework, you've already got your Chromebook out because you're looking at the problems. And if there's one that you run into, you're like, wow, I just don't get this. I just need a little more help on it. Can we go over it in class? Just click on this form, put your name, just so that if there's something I need to follow up with, I can do that. Tell me which period you're in. Tell me the page number and the question number. And then if there was something like I just got stuck here or whatever, you can tell me where you got stuck just so that we can make the most efficient use of our time, okay? And then if you would like to do it outside, like if you want to just come in during Liberty time to talk about it, if that's the kind of question it is, that's totally fine too. Otherwise in class. And then I will use this at the beginning, like during first period, I'll take a look. And if there's anything there, I'll be like, oh, okay, this one we're going to talk about during fourth period. Does that make sense? That just will, I think, help make things more efficient. And I also hope help you keep it in your brain because sometimes in the middle of a class, do you have any homework questions? Well, I don't remember because I was doing that last night. I have no idea right now. So that'll be like, oh, we're going to go through numbers 3 and 5 and then we can just do it. Okay? So please utilize that. If you don't utilize that, I'll probably still ask for questions now and then, but this is going to be your biggest tool to help me out. Okay? All right. That's all the logistical business that I wanted to share with you. On Friday, we worked on a lab, and the lab that we worked on involved the motion detectors. There's a lot of little chit-chatty conversation I'd really appreciate if that could stop because it's really distracting to me. Okay? Thank you. On Friday, we had these whiteboards out, and we used motion detectors, and we were walking back and forth to make position versus time and velocity versus time graphs. Okay? And those of you that were here, I think it was a really good experience. You kind of got to play with and figure out how those graphs worked. If you were not here, I'm going to give you the choice about whether or not you need to come in to do that. Okay? It is not something that's going to be graded or assessed, so I'm not going to say you must come in to do it, and I know that some people are crazy busy. If you would like to come in, I would strongly encourage you to, and you can come in during Liberty time or before after school. Like, you tell me when and we'll do it, okay? Otherwise, I would definitely take a look at the lab so that you understand it. Regardless of whether you were here on Friday or not, we're going to do this warm-up problem together that's related to it. Okay, so on this warm-up problem, I'm going to ask you in just a moment, excuse me, to make a prediction by drawing graphs of position versus time and velocity versus time of my little setup that I have here. If you can't see this setup right now, you might want to move so that you can. I'm looking on the floor here. I don't have another table. So if you're in the back, come on, just stand up so you can see this real quick. So I've got a track. It's the same tracks that we used for the marbles to run down. Then I have a cart. You're going to get to know these carts pretty well later in the year, but right now it's just a cart. It's got its own little handy-dandy whiteboard-like thing going on here. Okay, and then I've got my motion detector, just like you guys had before. Okay, and what I'm going to do, I'm going to show you what happens so that you can stop and make your prediction. So I'm going to lift up one end, and then I'm just going to let it go. It's going to go like that. Okay, and what I would like you to do is to make a prediction. What does the position versus time graph look like? And what does the velocity versus time graph look like? Okay, I'm going to let you go ahead and do that right now. Draw them on your paper, and then there's a whiteboard in front of you, probably, and if there's not, you can make it so that there is. Okay, draw those two graphs and also describe the motion. All right, I'll give you just a minute or two to get started on that. I want to know what your predictions are. So let me see your graphs. Show me your graphs. Let me see what you got. Okay. Cool.
Dun, 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 dun.
All right. So I'm seeing some good.
Oh, you didn't see mine yet.
Oh, I did. I love it. It's beautiful. Thank you. So I see a lot of. My stylus has been really crabby today. We'll see how this goes. I see a lot of this, and I see a lot of this. Does that kind of match with what you've got? So your position versus time graph is a curve. Your velocity versus time graph is a straight line with a constant slope. I need some words here. I want some vocabulary, some text to describe that. Who can give me something, some information about the motion? I'm looking for things about acceleration, about velocity, about direction, about position, those four things. You got one for me, Dimitri? What you got?
It accelerates.
It accelerates. Awesome. What else you got? That's one. There's at least four things that I want to know. Give me another one.
Positive slope.
What has a positive slope?
The velocity.
The velocity graph has a positive slope. So there's a positive slope for the velocity versus time graph. And as a result, what? There's a positive acceleration. Awesome. Awesome. Getting it mixed up. Yeah, go.
The velocity was constantly increasing.
Velocity is constantly increasing. If you don't have these words or these descriptions written down, I would strongly encourage you to do that so that you've got this stuff in your brain and you can kind of conceptualize what's going on. All right. What else? So you got acceleration, you got velocity. Tell me about the position. What's happening to its position?
Moving away from the
It accelerates, but what was the velocity again?
Sorry, my handwriting got really nasty there. Velocity is constantly increasing. Kelby, did you have something?
I was just going to say increasing position or increasing slope in the position.
Yep. So the position versus time graph, those are two things. And I think, Hunter, you were going to maybe say one of those as well.
moving away from the order.
Okay, hold on a second. So increasing slope, which gets us back to the constantly increasing velocity. And then, but you also said what? What about the direction it was going? It's going in a positive direction or moving, can I say moving forward? Is that okay? Was that what you were going to say or did you have something else? Okay. How are we doing? Okay.
I got velocity constantly increases and position accelerates.
So you may have noticed, physicists, you may have noticed that I like charts. I like to organize my thoughts and my ideas in charts. It's the way that makes sense to me, and I hope that if nothing else, it is not detrimental to your learning. I hope that maybe it helps you to organize your thinking as well. So we've been talking a lot about motion. We've been talking a lot about one-dimensional motion, and we've kind of been talking about signs, positives and negatives, but we really haven't talked a lot about what they mean. And I want to do that today. So we're going to do that with this little fairly quick activity. So the game is really, it's pretty simple. We've got positives and negatives, okay? Positive velocity and negative velocity. Positive acceleration and negative acceleration. And I'm going to ask you and your partner or partners to have a quick conversation about what it means for an object that has a positive velocity and a positive acceleration. And by that I mean, is it moving forward or backward? Is it speeding up or slowing down? Okay? So you're going to answer each of these questions in each of the 4 boxes. All right? And I want you to just kind of chew on it for a minute, discuss it, see if you can come up with some examples to understand what's going on. We're gonna touch base again in a second, but go ahead and have that quick conversation right now. And if you don't, I want you to challenge yourself in the next few days as we're going through this stuff to feel like you don't have to have things perfect, okay? If you need another copy of something because the first time you mess it up and you're a person that really likes to have everything nice and neat and tidy on a piece of paper, then let me know and I'll give you 2 copies of something. In fact, you can just take 2 copies, that's fine, okay? What I want is for you to get dirty and messy and figure this out, because that's the only way to do it. Just learning from me telling you something, it's not gonna stick. It's just not in the same way. All right, we're gonna give this a shot. We'll see how we do. All right. So the question is it moving forward or backwards, speeding up or slowing down? I want to start with velocity because velocity is the easier of the 2 to kind of think about. Okay? If you have a positive velocity, if an object is moving with a positive velocity, what does that mean about its motion?
It's moving forward.
Moving forward. Does that make sense to people? Yeah. I think that's okay. I think that's an okay statement. We'll talk about why that's really true, but let's go ahead and write that down. It is moving forward. I'll write that actually. Well, I'll just say forward. Forward motion. Okay, it is. It's moving forward. And does it matter what's going on? Always, always. If it's positive, that means it has forward motion or it's moving forward. So if it's positive, it's moving forward. I'm guessing your claim is going to be that it's different if it has a negative velocity. Is that true?
Yep.
Yeah. What's it doing if it has a negative velocity? It's moving backwards. Actually, I'm going to swap that. I'm writing these in different forms. I apologize if that bothers you. Now, that may just be kind of logical, but I want to make sure that you feel confident. Maybe your neighbor got that, but maybe you weren't there. So let's make sure that this makes sense to you. Let's remind ourselves what velocity is. Remember, velocity is just change in position over time. Are you with me there? Okay, so that means that it's the final position minus the initial position over time. Okay, so if you take the final position and it's bigger than the initial position, bigger than the initial position, that's going to be a positive number.
In the orange up there?
And I just have the definition of velocity.
Which is?
Change in position divided by time. Is that better, Dimitri? Can you see it better now?
Yeah.
Okay, great. Thanks for asking. And keep asking those questions if you have them. So if we tried an example, let's say that we have a positive change in motion. So maybe our initial position is 3 meters and our final position is 7 meters. Then 7 minus 3 is 4 meters. Yeah, is everybody cool with that? And if that happened over 1 second, then the velocity is 4 meters per second. That is resulting in forward motion, and it's a positive velocity. Okay? Quick question, because a lot of people said this and I wasn't sure. I didn't know if I heard it in this class or not. Does a positive velocity mean that you're going away from the origin? Is it possible to have a positive velocity and be moving toward the origin? Yeah, Philip, can you think of an example of that? Or how would that happen?
Like, it's just your final and initial, so if you started away from the origin, if you're moving towards it.
As long as you're moving in the positive direction, right? So if I started with an initial velocity of negative 9 meters, and I had a final velocity of negative 2 meters, then I've got negative 2 minus negative 9, there are meters is there, and that's going to be a positive 7 meters that I traveled, right? Positive 7 meters in 1 second, that's going to be a positive velocity, even though I'm going toward the origin. So I just want to make sure that that's in your brain too. That just because you have a positive or negative velocity, that doesn't mean that you're moving toward or away from the origin. We're just talking about the direction of travel. Okay? The negatives are going to be opposite, so we're going to have, that means it would be going like from 7 to 3. So you're going to have a negative 4, you subtract, and that's where you're getting the moving backwards. How are we doing on velocity, friends?
Good.
Okay, that was the easy half. We're halfway there. So now the question comes to acceleration. The question now is the object speeding up or is it slowing down? What does it mean to have a positive acceleration? A positive acceleration means that the push is going in the positive direction. Positive velocity, moving forward, and a push in the positive direction, what's going to happen? Is it going to speed up or slow down? It's going to speed up. It is. Okay. A nice example of that, if we're just trying to think of examples, a nice example of that would be, I always think about being in a car, and my apologies to you if you are not someone who drives a car, but I think that all of us have at least ridden in a car or a bus or some sort of transportation like that before, even if you haven't actually been the one at the wheel. But if you have a positive velocity and a positive acceleration, that would be like you're in drive and your foot's on the gas, right? Yeah. So I'm just going to write that down just to kind of remind you. We're in drive and your foot is on the gas. Okay? For sure. Okay. Now, let's say that you've got a positive velocity and a negative acceleration. So now you're moving forward, but the push is coming the other direction. What's going to happen to your motion? Are you going to speed up or slow down? What do you think? Let's vote, because I'm hearing like 2 people. There are more than 2 of you in here, right? That's the beauty of a big class. We've got lots of people. Raise your hand if you think, in this case, a positive velocity, a negative acceleration. Raise your hand if you think that we're going to speed up.
No.
How about slow down? Yeah. We are going to slow down. I see some people that were not voting, and I'm a little bit nervous about you, friends, because I want to make sure that you understand it. So I don't want you to just be asking your friends and like you need to get it. So I want to make sure you understand it. I would like to do a quick double check to make sure that makes sense to you. So we're going to slow down. That's what the consensus of the class was. But let's just make sure that fits okay. Just a friendly reminder of what acceleration is. Remember, acceleration is change in velocity over time, right? That's velocity final minus velocity initial over time. Okay. So if we've got a positive initial velocity, okay, and a negative acceleration, I want to figure out what's going to happen. So I want to find out what my final velocity is going to be. Okay. So here's the situation that I would like you to solve. I'm going to say that I've got an initial velocity of 8 meters per second. We all agree that that's positive? I've got an acceleration of negative 2 meters per second squared. And we're just going to do this over 1 second just to keep it easy. I'm going to go ahead and plug these numbers in. We're going to practice this a lot this week, but just to keep it kind of simple here. So I've got a negative 2 meters per second squared is equal to the thing I don't know, that's what I'm looking for, minus 8 meters per second divided by 1 second. Why am I doing this? Why is she making us do this? I'll tell you why. Because sometimes I don't know the right answer to this, right? I have to think it through. And for me, the math won't lie. as long as I don't screw it up. I totally screwed it up earlier today. But I know this one is going to work, okay? So let's take a look. I'm going to multiply by 1 on both sides to get rid of the 1, okay? And then what do I need to do to this 8 to move it over here? I'm going to add 8. Negative 2 plus 8 gives you, 8 minus 2, essentially. Sorry, I said that backwards. This is what happens sometimes with arithmetic for me. The final velocity is what? 6. 6 meters per second. Let's compare the initial and the final. Here's the initial. Here's the final. We slow down or speed up, friends? We did. Indeed, we slowed down. Okay? If we're driving a car, we're still moving in the forward direction, right? That's what it said, forward motion. So we're still in drive. But what pedal is our foot on now? It's on the brake, right? It's pulling the other direction. How are we doing? Okay. We are almost there. We only have 2 boxes left. Now, for better or worse, they're the 2 more confusing boxes. So let's give it a shot. Let's see here. Now, we're moving in the negative direction. We have a negative velocity. I want to know if a positive acceleration, so the push, friends, there's a lot of conversation that does not need to be happening because then I'm afraid that you're going to tell me tomorrow that this doesn't make sense and that you're confused. And I'm going to say, we really just did this, okay? I'm going at a pace that I think is fair, but I don't want you to then not listen and then be confused, all right? Negative velocity, I move in this direction. My push is going this way. Think about that for a second.
What? Which direction versus?
So I'm going this way. I'm moving this way. My velocity says I'm going backwards, right? This is backwards. Back. But my push is in the positive direction. What's going to happen to my motion?
You're gonna slow down.
This guy says I'm going to slow down. Shall we vote? I don't know about Dimitri, I don't know each other well enough. I don't know if you know each other well enough. Do you want to trust him on everything he says? Or you want to think through? Because I don't know. Raise your hand. Do you think that it's going to slow down? Anybody else? Yeah? Raise your hand if you think it's going to slow down. There are a few of you. Raise your hand if you think it's going to speed up. A lot of people say speed up. My guess is, let me ask. My guess is that you say speed up because this is positive, right? Seems to make sense. If the acceleration is positive, it should speed up. Okay? Y'all looked at me a little bit goofy when I did this one because I wanted to test it and make sure it was true. We're going to do the same thing for that negative velocity, positive acceleration. So here we go. I want you to write this down as well. I'll give you some numbers to plug them in so that it's not too scary or confusing. Okay? I'm going to give you some numbers. So here, let's do an acceleration of 1 because we know that's positive. Let's do an initial velocity of -7 meters per second because we know that's negative. We're going to keep it simple, so we'll keep our time at 1 second. And let's figure out how fast we're going after, okay? So again, I've got a positive acceleration. I've got a negative velocity. I want to solve for the final velocity to find out if I'm speeding up or slowing down, okay? So let's go ahead and plug that in. I'm going to move this over a little bit, knowing that my equation is that I've got acceleration, come on, 1 meter per second squared is equal to my final velocity that I don't know minus my initial velocity that is negative divided by my 1 second of time. Again, I like to keep things simple when I'm trying to figure these out. I don't want to have crazy numbers. 1 times 1. Can we do that one? That's 1, right? And then I've got minus a negative. What does minus a negative do? Adds it up, right? Plus a positive. So I've got 1 equals VF, that's really meters per second, plus 7 meters per second. I need to get rid of the 7. How do I undo the 7? Subtract 7 from both sides. 1 minus 7 gives you?
-6.
-6. Oops, I just wrote 7. Come on. -6 meters per second is equal to VF. So now we have to think. Oh man, we have to think. What? Jeez. Okay, initial velocity was -7. Final velocity is -6. Is that speeding up or slowing down?
Slowing.
Remember, speed is just the magnitude or the size, how fast you're going. Okay? Make these bigger numbers. Maybe make this 70 miles per hour and make this 60 miles per hour. Are we speeding up or slowing down going from here to here?
Definitely slowing down.
Does that make sense? Mel, you're looking at me like I'm a little bit goofy. Because it's negative. You want it, right? You're like, negative. What the heck is negative? That is so true. And this is why we're having this conversation, friends. Because the negative is just for the velocity. Do you remember forever ago when we were defining speed? We said speed is just the distance over time, right? So that's kind of what your speedometer is telling you, right? Is your speed. The direction doesn't matter. Okay? The compass in your car tells you your direction, but your speed is just the size. So you've got 6 meters per second is our ending speed. 7 meters per second was our starting speed. Are we going faster or slower at the end? We're going slower. I know. It's weird, right? It's super weird. So this situation, let's see if we can talk about it in terms of us driving. Okay? So we've got a negative velocity. That means, are we in drive now? We're in reverse, right? You put it in reverse. Okay? So what's that?
Wait, you're going 70 miles an hour in reverse.
No, friend. I was just trying to get it conceptualized because some people are like 7 and 6. What's that? I just multiplied by 10 just to give you a sense of what was going on. I would not recommend driving 70 miles per hour in reverse.
Unless
That is
you're a backwards
not
driving expert like
A
Vader.
recommendation from Ms. Carville. I want to make that very clear. All
Unless
right.
you're like Tub Vader.
Right.
Without the tub.
Yes. Thank you for that reference. I appreciate that. All right. We're driving in reverse. And it says, oh, wait, we didn't even write it down. What did we decide? We decided we're slowing down. It's weird. It really is. The reason we're spending time on this, and I didn't just like assume you knew, was because it's weird. That's exactly why. So we're going backwards, but we're slowing down. So which pedal are we on? We're on our brakes, right? Yeah.
That would be like going 70 miles per hour. There's a car coming at you the other way. Ah!
I feel like you've been watching a lot of goofy movies, my friend. Okay. Now, this whole column, all of this negative velocity stuff is weird. Yeah, you guys are, I think you've probably been convinced of that already because it seems kind of goofy. I'm going to give you a very different example for this last one. Okay. A little preview as to what we're coming into next. Have you guys met my frog yet? I don't know if you have. This is my frog. My frog likes to do physics. My frog's been with me for a really long time. Okay. Right now,
Yeah,
my frog
his
is.
design is a bit outdated, so
I know, but I still love you. It's great. Okay, here we go.
Yeah,
Aw.
it's cool.
All right.
I love the rainbow colors and all.
Me too. All right, so here we go. So here's the frog. I'm going to let him go. And while I do, I want you to watch his motion. And kind of like the ball on the ramp, it probably won't blow your mind, but I want you to think about it carefully. So watch. Are you ready? Here we go. Okay. What happened to him? He fell. He did not die. He did not die, but he fell. And he's going to fall a lot this year because that's what he does. So he's going to fall. Now, tell me about his motion. Where did he go? Which direction did he move? Down. And generally, when we're talking about things in the vertical axis, when we're going up and down, which one do we call positive? Up or down? Up, right? So if up is positive, then down would be negative. And so if he's traveling downwards, that means he's moving backwards. Everybody okay so far? Now, when I release him, tell me about his velocity right at the beginning. What's his velocity right when I let go?
Somewhat slow.
Like, it starts off at 0, right? Because I let him go. And then does he stay at 0? No, that would be weird. Would you agree? If he just like hung in the middle of midair, like that doesn't happen. So he starts to
It
fall.
happens if you've got a string attached.
I know, but I don't, right? So I let go and he starts to fall. Now, when he falls, does his velocity change? Let's watch. Answer?
Yes.
Yes. Yes, it does. Because if you watch the amount of time it takes to go from here to here, it takes a long time. as compared to the amount of time it takes to go from that same distance down here. Are you with me? Okay, it goes fast down here.
That's because of gravity.
It is. You are so right. So, is the frog accelerating? Indeed. Which direction do you think he's getting pulled?
Down.
Down, right? Which means he has what kind of acceleration? A negative acceleration. So he's got a negative velocity because he's going backwards, going down. And he's got a negative acceleration because he's being pulled down. So he's being pulled in the same direction he's moving. And what happens to his speed, guys?
It speeds up.
Oh, it increases. He speeds up. Welcome to Brain Blasting Monday, right? It's a great thing. That is what happens. He speeds up. Now, that's not only true of a frog. That's also true of a person driving a car. In what case? Tell me what this is now. So this is going to be we're moving in the negative direction. We're moving backwards. So we're in
with the gas
reverse. Yeah. Now, some people laugh. They're like, why would you do that? Well, you do that every day when you pull out of your garage or you pull out of your parking spot, right? Like when you pull out, you're in reverse and you start at 0. So you have to put your foot on the gas, not like hard, like you're not going to slam it, but you got to put a little bit. Otherwise, you're not going to go anywhere. Yeah. Okay. How are we doing, team? We doing okay? So the thing that I want you to get from this, the thing that I want you to kind of internalize here is that the speeding up happens when the signs are the same. Okay, I'm going to write this down. You might want to write this maybe up in the top corner or in the bottom, somewhere where you have a spot. Okay? The thing that I want you to retain from this all is that when the signs are the same, the object speeds up. Okay? When the signs are different, what happens? It slows down. Okay. On the back of your yellow sheet, there is a chart. And this chart kind of helps you to articulate the same idea, just in a little bit more detail. This is what I would like you to work on right now. And whatever you don't finish from this will be your homework for tonight. The other homework that was listed, don't worry about, we'll get there, okay? This is what I want you to focus on, assuming that you work well for the next minute and a half or 2 minutes. If you all put things away, then I will be happy to give you more homework for tonight, okay? So good faith, work on this for a minute or so before we move on, before that bell rings, okay?